Alright, in today's video we're going to be looking a little closer at some of the attributes of those linear functions. First off, some of these key attributes of a linear function. The domain of a linear function is always going to be all real numbers. Okay? The domain is the x values. We can have any possible x value in a linear function, so it's all real numbers. The range of a linear function, or the y values, is also all real numbers. Okay? There are no limits on the domain and range of a linear function. There is not a maximum or a minimum value on a linear function. It keeps going on and on forever, so it does not reach a maximum or a minimum. Linear function has one x-intercept, and that can be found at y equals 0. And it has one y-intercept that can be found at x equals 0. So let's look at some of these examples. First, let's look at finding these things from a graph. If we look at this graph here, our x-intercept is where this hits the x-axis, which will be that point there, which is the point 6, 0. Okay, notice our y value is 0. The y-intercept is found here, is at the point 0, -3. Almost wrote that backwards. Okay, now you notice down here it says D and R, that's domain and range. Now, it's asking for set builder notation. This is something you may or may not have seen before. But basically, the way we say all real numbers in set builder notation is we write a curly bracket, x such that x exists in reals. And that's what all those symbols mean. X such that x exists in reals means all real numbers for x. Now our range, we write a curly bracket again. We do y such that y exists in reals, because y can be any real number. Alright, let's look at our second example here. You'll see our x-intercept where it hits the x-axis is here. That is the point 2, 0. And then our y-intercept is up here. It's found at the point 0, 6. Again, our set builder notation, curly bracket, x such that x exists in reals. And our range is y such that y exists in reals. Okay, let's look at a couple more examples. Right here, you're going to notice it crosses right here at the origin. So it crosses the x and y axis at the same place. Both of those are 0, 0. Notice now we have interval notation. How do we say all real numbers in interval notation? We say parentheses, negative infinity to positive infinity. All real numbers for the range would be negative infinity to positive infinity. Okay, let's look at one more graph. Here you'll see our x and our y-intercept. We hit the x-axis at -2, 0. And we hit our y-axis at the point 0, 4. Our interval notation is exactly the same as it was before for all real numbers. Negative infinity to positive infinity. And our range is all real numbers, which is negative infinity to positive infinity. Okay, now what if we were no longer working with the graphs? What if we were looking at the actual functions? Well, the way we would find the x and the y-intercept for something like this would be, well, The x-intercept is where y equals 0. Okay? Well, if y equals 0, we would then solve this. We have divide both sides by negative 1/4. We get 0 equals x plus 8. Okay. Subtract 8 from both sides, and we get x equals negative 8. Okay. Now our y-intercept is found where x equals 0. So I'm going to do this on top here. 0, we're going to put 0 in for x. Okay. Negative 1/4 times 0 plus 8. 0 plus 8 is 8. Negative 1/4 times that. Plug that in the calculator or work it out by hand, whatever works best for you. We get 0, comma, negative 2. Set builder notation would be the same as previous. We have x such that x exists in reals. And we have y such that y exists in reals. Okay, so let's look at this next example here. X minus 2 plus 5. Again, to find our x-intercept, we make y equals 0. Y equals x minus 2 plus 5. Alright, so now let's just go ahead and solve this out. 0 equals x plus 3. Subtract 3 from both sides. And we get x equals negative 3. Alright, and now for our x-intercept, or our y-intercept, I'm sorry. For a y-intercept, we're going to put x equals 0. 0 minus 2 plus 5. Well, 0 minus 2 is negative 2 plus 5 gives a value of 3. So our y-intercept is found at the 0, 3. Set builder notation, we go ahead and fill that out as x such that x exists in reals. And y such that y exists in reals. Okay. Alright, so let's look at one more with the equation. Again, to find our x-intercept, we want y equals 0. Okay, now we're going to solve this for x. Subtract 4 from both sides. I'll go ahead and write the steps out on this one since I have a little more room here. Negative 4 equals 2x. Divide both sides by 2. And you get x equals negative 2. So our x-intercept is negative 2, 0. Alright, so now let's find our y-intercept. Y equals 2x plus 4. Okay. Y equals 2 times 0. Substitute 0 in for x plus 4. 2 times 0 is just 0, so y equals 4. Our y-intercept then is 0, 4. Interval notation. All real numbers for a linear equation, negative infinity to positive infinity. Our range is all real numbers, negative infinity to positive infinity. Okay. One more time, if we were looking at the table and we wanted to find the x-intercept and the y-intercept, remember the x-intercept is where y equals 0. The y-intercept is where x equals 0. Well, where y equals 0 is here. So our x-intercept is the point negative 1, 0. Our y-intercept is where x equals 0. And that's going to be our point 0, 1. Let's look at number 9. Do this one more time. Okay, our x-intercept, We're looking for a y value of 0, which we find there. So our x-intercept is at 2, 0. Our y-intercept, we look for an x value of 0. So our point there is 0, 6. Last one real quick. X-intercept is where y equals 0. That's the point negative 2, 0. And our y-intercept is where x equals 0, which in this case is the point 0, 1.